Hello everyone. Today we're going to talk about multiplication of vectors. In mathematics, we learned that there are multiplication of numbers, but how about vectors? Since vectors have direction and magnitude, they are multiplied in a different way. There are two types of multiplication of vectors, cross product and dot product. In this video, we will talk about multiplication of vectors using dot product and its application in our daily life. Let's
Before we
begin.
discuss about dot product, first we need to identify the differences between vector and a scalar. Vector consists of both magnitude and direction, but scalar only has magnitude. Dot product is the multiplication between two vectors to produce a scalar, and that is why dot product is also known as a scalar product. So, if a vector A multiplies a vector B using dot product, we will get the magnitude of vector A times the magnitude of vector B cos theta, and theta is the angle between the two vectors. And let vector A is A1, A2 and A3, and vector B is B1, B2 and B3. We will get the formula, and that is the vector of A multiplied by the vector of B using dot product. We will get A1 times B1 plus A2 times B2 plus A3 times B3.
Okay, now I'm going to talk about one of the application of the dot product, which is work done. In general, the formula of work done is W equals to Fs. But we cannot use this formula because if we use this general formula, we are neglecting the direction of the force and also the displacement. Force is a vector quantity, and same goes to displacement. They both have the direction and also magnitude. So, in order to get the right definition of work done, we have to use another definition. That means that we are calculating the work done, including both of their direction and also their magnitude.
How can we define the work done in a more precise way? So we can use the dot product. Okay. Vector f can be written as fx equal to f cos theta or fy equal to f sin theta, where fx is the horizontal component of the vector f, while fy is the vertical component of the vector f. Okay, say that we use the horizontal component for this model done. Okay, we can make it w equal to fxs. So substituting fx with f cos theta, we get f w equal to f cos theta s. So w equal to fs cos theta. Therefore, w equal to f dot s, where w is the work done, f is the vector of s, f vector of f, while s is the vector of s.
By now, you will have to bear in mind that work is based on components of force in the direction of the displacement. So it is easy to calculate work done if the displacement is in straight line motion. What if the displacement is in a curved line? Consider an arbitrary curve where f is acting at the point of curve in this way. So we can calculate work by drawing the components of f in horizontal component and vertical component, which is f in this vertical component, f sin theta, in horizontal component, f cos theta. We can see that f cos theta is in the direction of the tangent at that point. So, in this case, we neglect f sin theta because there is no displacement in this direction. So we do not need to use F sin theta in our definition of work. So we can write this as work is equal to F, the horizontal component of F, which is F cos theta, times vector R. Therefore, this can be rewritten as F R cos theta, and back just like the other previous explanation, work can be written as F, the vector F times vector R. This is only at one point, at any point of this curve. Now we have to calculate work throughout this curve. Therefore, we must apply the concept of calculus, which is the integration. So we have to integrate R. We have to integrate R from R1 until R2. Therefore, R will become F dot product with dr from R1 until R2, R1 until R2. So therefore, this is the most accepted or most precise definition of work that work by using dot product.
So basically, why we use dot product instead of cross product? Dot product, okay, for example, F is a vector, so do S. So force and displacement both are vectors. So the work done is in scalar position, in a scalar. So scalar means they only have a magnitude. So when you use F force in terms of direction and in terms of vectors, and also displacement in terms of vectors, to produce a scalar product, so we must use dot product, because cross product is for vectors multiply with vectors to produce vectors product.
Now let's look at the example after we have heard a lot of explanation. For a better view, let's look at the solution. Okay, first evaluate vector F dot product change of vector R, where vector F is equals to x square y square plus y, where and C is y square equals to 4x in the x and y plane from 0, 0 to 4, 4. Okay, first we change y in terms of t. This is y equals to t. Then we substitute t into y square. So t square will equals to 4x. So x equals to t square over 4. And for the limit is 0, t is more than 0 and 4 is bigger than t. Now let's look at the vector r. So vector r is equals to t square over 4 t. When we differentiate vector r, we will get t2 1. Okay, for vector f, we substitute the value of x square, y square with t square over 4 and t square respectively, and also t for the y. Then we will integrate the vector f dot vector r, change of vector r. So we will get this equations. Then we will do dot product. The T4 over 16 will time with T over 2, T will time with 1. So this is the result. Where it will go and it will go further integration and you see the answer. This is the this integration.